I wanted to give you guys from Riot a huge shout out for enabling all this fantastic lunch and learn and the community events. It's so useful. So definitely appreciate all you guys do. So like Lauren said, Dave Hoover, I'm the Vice President of Advanced Technology at Connected Development. I'm going to introduce the company a little bit more in a couple slides, so I'll get to that. The topic of the day is to talk about LoRa and LoRaWAN, and really how do you enable chipset designs quicker. So some of the pitfalls of doing a chipset design, how you get around that, what we could do to help out with those types of designs at the end of the day. LoRaWAN and LoRa are hugely popular these days, very useful for IoT type development. So we'll get into a lot of details on that. So the agenda, obviously we'll go through introductions. Like I said, I'll introduce the company a little bit more in a slide or two here. I'm going to talk about LoRa and LoRaWAN at a super high level. It's not meant to be a deep dive onto the technology necessarily, but I want to make sure that we're all level set and that everybody understands what all we're aiming to cover, and show a little bit on what LoRa is good for and what it's not. Talk about SumTech. Obviously, SumTech and LoRa are kind of synonymous in a lot of ways. We'll talk about the chips that we're covering here in this discussion. Some of the challenges of doing a chipset design, what can go wrong at the end of the day, and what does go wrong in a lot of cases, and how we can help out with various resources with reference designs, things like that, that make that process a lot easier for end developers. We're going to go into a little bit of a deep dive on the resources we do have. I'll go through what types of resources we have on hardware as well as software, how to get that set up at a high level, where to go to get those training tools and such. And then shift directions just a little bit and talk about Amazon Sidewalk. For those who don't know, Amazon Sidewalk has certainly some LoRa components and as well as some other things. So it's definitely a hot topic these days. And I'll go into how this design can also fit into Amazon Sidewalk type of implementations. And then we'll conclude and talk about how we can help out with these types of solutions at the end of the day. All right, as Lauren said, if any questions come up during the presentation, just put them in the chat. We'll address those at the end. I expect that this presentation will be somewhere between 40-45 minutes, somewhere around there, and then that'll give us some time to answer questions at the end if there are any. Okay, so who Connected Development is. So I'm going to start up by who owns us, and then we'll get down to who we are. So at the end of the day, we're a Berkshire Hathaway company. So somewhere up the food chain, report to Warren Buffett, I guess. I've never met the gentleman, but just we're part of a much larger organization. We're a design services company. I'll get into that in a second, but we're owned by the TTI family of specialists, which is, for those of you who do not know, TTI is one of the largest distributors on the planet. As part of that family is TTI themselves, again, large distributor. Mouser, a lot more people know who Mouser are, catalog specialty distributor as well. Sager, another distributor. And then we fit in here under this exponential technology group. So that's why you see this E to the X little logo up in the corner, is that we Connected Development are part of this group called the Exponential Technology Group, which is comprised of some specialty distributors. Symmetry is a very IoT-centric distributor. Changnam is based in South Korea, and RFNW, as the name kind of suggests, specializes in distribution of RF type of components. We are one of the design services companies that's part of this family. So you'll see down here, Connected Development, Paragon, and BGM. All three of these are design services companies. So we're based in Raleigh, North Carolina. Paragon is in Dallas, Texas, and BGM is a little bit more automotive centric. They're up in Detroit. So between the design services companies, we specialize in wireless designs, IoT designs. We do everything from soup to nuts. So you can bring a design interest for concepts We'll take it all the way from that first design through the implementation of the design, all the way up through RF antenna design, testing, certifications, and even up through manufacturing. We've got hardware engineers, firmware engineers, RF, project management, everything you need for designing an IoT product. Okay, so jumping up to the super high overview of what exactly is LoRa. Yeah, I'm sure a lot of people know this, but again, want to make sure everybody level sets on where this presentation is built off of. LoRa is basically used for low bandwidth, very long range communication, wireless communications. So when I'm talking long range, if you've got line of sight, you could go miles with it. Obviously, if you're in a dense urban environment, you're going to get different results at the end of the day, but very good at building penetration, very good at long range communications. Not good, obviously, for high bandwidth. So you're not going to want to be doing video transfers or streaming or anything like that with LoRa. But if you're doing more industrial IoT type applications, then it's really great for that. LoRa does provide a fair amount of flexibility in how you set it up. So you can set it up to be super long range and very, very low bandwidth, or maybe if you don't need quite as much range and a little bit more bandwidth, you can set up to that. You can twiddle with the bandwidth and spreading factors, coding rates, things like that to make those trade-offs between long range and data rate. Really are usually the two things you want to play around with on that. So compared to other technologies that are out there, other IoT technologies and wireless communication technologies, how's it compare, right? If you look at cellular, for example, cellular communications, that's obviously good for long range. It's obviously good for putting a device anywhere and getting connectivity very quickly. You're not going to get as good a battery life out of it. Certainly the costs for the modems and your end design is going to be higher. Obviously, there are different levels of cellular connectivity that you could choose from. There are the higher category LTE devices, for example, where you can do that video streaming and things like that, all the way down to very specialized low bandwidth type of cellular communications like LTE Cat-M, for example, or narrowband IoT. For the purpose of this discussion, those lower band cellular communications are more kind of comparable to LoRa, but still you're going to get way higher costs on your devices, and you're going to get higher battery life and things like that. So you know, LoRa is really specialized for those very low bandwidth cases. And then obviously you have Wi-Fi. It's interesting. Wi-Fi used to not, well, I'd say over the past few years, it's been making a resurgence in terms of IoT applications. It used to be that it was kind of a no-go for IoT applications with Wi-Fi due to ISIT considerations and getting onto clients' networks, especially in hospital applications, things like that. It's making a little bit of a resurgence, but again, a different beast. That's aiming for kind of that medium distance type of thing and large amounts of bandwidth. And then Bluetooth kind of goes down towards the very battery efficient, but obviously very range constrained. Okay, so what kind of applications should be targeted for LoRa, right? You can kind of think about what I just said and extrapolate that a little bit to what types of applications would you go and use for that. Again, long range, things that you want to be campus-wide applications, for example, building-wide applications. Again, good penetration capability, good length and distance on these things. So that's a good place to aim for anything that's building management, for example. Battery life, things that need to run on a battery for really long periods of time, and I'm talking, you know, many months or even years. You know, LoRa is a good technology for that type of thing. The high capacity, you can put a lot of units onto a LoRa network, right? So that's definitely something that's well served by LoRa. Low cost compared to some of the alternatives, especially cellular. That's important. You could do location type things. You could do photo over the air update of your firmware. And then you could do some, your device can be mobile and moving around and still track it. Security, the LoRa standards have security built in from end to end. That was there from day one. So you've got encryption and everything is built into the standard. So it's a very secure type communication methodology. So taking that a little further, in terms of verticals that kind of fit the bill on this, obviously things like you see here, energy utilities, smart cities, building automation is huge, smart agriculture, industrial IoT, things like that. And then there's lots of other examples in here. The key is to look again for those things that don't communicate very often and communicate with very small payloads. So you have to make sure that it's suitable for that type of thing. If it does that, then it's a great technology to go after there. All right, so LoRaWAN, this gets a little confusing, right? So you hear LoRa a lot, and then you hear LoRaWAN as well. But what in the world is LoRaWAN? So LoRa is specifically referring to the lowest level physical link, the wireless link on how to get the bits back and forth from point to point, right? So it's the physical layer of transmission. LoRaWAN is built on top of that. It's the networking protocol that goes on top of LoRa itself, right? So you can imagine, like, you can use LoRa, and we'll get into some examples of this in this presentation later on, but the point-to-point side without LoRaWAN, you can use for proprietary point-to-point communications, which certainly can be useful for a lot of different applications. If you have to have an asset communicating with another asset, or communicating directly to a gateway without having to connect up to the cloud, or whatever it might be, then LoRa would be sufficient. But as soon as you want to have many devices connected up to the cloud and have the cloud communicating back to those devices, clearly you would want some way of standardizing that, right? That you don't want every, how do you authenticate those devices? How do you provide security for those types of things? How do you join up to the server? Things like that need to be taken into consideration. How do you address the devices coming back down? All that is what LoRaWAN takes care of. So if you look at this networking, well, first of all, this is just basically a picture of the end devices out here talking through gateways, and then they talk up through the various pieces of a LoRaWAN infrastructure. So you have to have things like the joint server, you have to have the network server, you have to have an application server. All these things are needed to authenticate those devices, make sure that they're allowed on the network, and make sure that the network can tell who's talking to it, essentially, and communicate back down. So if you look at the kind of the OSI layer picture of the world, you can see that at the very bottom, you have the channel and frequency schemes. LoRa obviously has different schemes for different regions. We've got the European regions 868 megahertz, 433 megahertz. Got the US is at 915. Australia has different frequency schemes. And then on top of that is built the LoRa modulation. Again, when you hear just LoRa, that's speaking of the modulation in the physical scheme. And then on top of that, in the yellow here, you have the LoRaWAN, the MAC layers and above, and the different classes of communication, which refer to whether the device can just talk and listen, things like that. So this presentation specifically is going to talk about a few different Semtech chips. There's this family that we're showing right here, which is basically the 12, we call it the 12.6X family, 12.6.1 and 12.6.2, as well as the LLC CC68 are the chips that we're specifically going to be talking about during this presentation. So the 12.6.1 and 12.6.2 are very, very similar. Actually, all three of these are kind of similar, but the 6.1 and 6.2 are very similar. The only difference between them is the allowed output power to them is the only primary difference. So the 62 goes a little bit higher in output power and can be used in North America. The 61 is a little bit lower output power, which allows it to be certified in Europe. So really, that's the only difference between the two that's of any note. And then the LLCC 68 is a stripped down version of those that only allows for certain spreading factors and data rates. It's a cost down version, only applicable for point-to-point type of communications. You wouldn't want to use that for LoRaWAN type of communications, but it's good for smart homes and applications that might be purely point-to-point and limited, right? All three of those variants are pin and footprint compatible. So in other words, you can have one PCB, one footprint down. You can take, take the same PCB and put any one of these three chips on, and electrically they will work. There will of course be some software differences in terms of setup and everything, but very similar in the way they operate, even on a software perspective. So these are the three chips that we're going to be talking about during this entire presentation. So doing a little bit of a deeper dive into the 61 and the 62, you can see that it's got coverage in terms of the frequency spectrum across everything that LoRa needs. So it goes all the way from 150 megahertz all the way up to 960. So it covers all the regions that LoRa could be deployed at. Supports all the LoRa modulations and spreading factors and such. So pretty ubiquitous there. And then you can see what I was talking about before, that the 1261 has got that lower output power, 15 dB, and the dBm, and the 1262 has 22 dBm. So that's, again, the major difference there. Both of them have similar sensitivity, low current consumption, and then different ways of setting it up in terms of the regulators that you want to set up, and you communicate with it over SPI interface. Again, pin compatible between the two. Very small package, 4 by 4 millimeter in terms of the physical size of the chip. And then the LLCC 68, as I mentioned, again, if taking it from the bottom, almost everything's similar on this. It's, again, that 4 millimeter by 4 millimeter QFN package. Everything else is pretty similar. It's got that transmit rate up to the 22 dBm, so similar to the 1262, but it's got a reduced number of possible spreading factors and bandwidths associated with it. So more of a limited application type of thing. So kind of getting into the beat of what we're going to talk about today, what kind of resources are out there? So Semtech has a legacy reference design that's available today. That's basically an Arduino Uno footprint, right? So basically it's a shield that has the 1261, 1262 on that shield. Semtech approached us was about a year ago to start developing something that was a little bit more targeted for real applications. So the issue with the current, the legacy, I should say, reference design is that it's not size optimized, and there's some components that can be optimized out. So what the challenge here is that if you take the reference design as is and you put it onto your board, it would work as it was designed, of course, but because these components were not size optimized in terms of the footprint, in terms of the layout on the PCB, customers that would take in this would take the schematics and then they would optimize their layout on their board, and the RF would be affected. So everything affects RF at the end of the day, and the results wouldn't be as expected. You wouldn't get as good of range as you were expecting, maybe not as good as sensitivity. You might even fail FCC. The RF just would be variable because it's being changed from the reference design down to the end board. So you can see some of the challenges here, right? That any changes at all can affect the RF. Antenna matching gets affected, harmonics can get affected, performance, stability, everything RF related starts getting affected once you make those changes. Because every design needs to be FCC certified and functional, RF functional, of course, at the end of the day, any such changes and issues can be a huge problem for the end customer, right? So Semtech approached us to say, hey, what if we instead of doing this, we we come up with a new reference design that's size optimized, that's RF optimized, that we know is operating the way that we want, and the customers can copy exactly onto their board. So that's where we came in and designed a new reference design board in partnership with Semtech. So the legacy board, for example, you can see here, it's maybe a little bit hard to see this, but it's this is the legacy reference design. This is the new reference design over here. So the legacy reference design, all of this is RF matching componentry, right? So this is how do you tune for particular frequencies? How do you tune for a particular antenna? All this stuff, I think if you count the components, are right around 10 passive components that need to be put into the design. And again, remember, all this is kind of spread across the legacy reference designs, Arduino Uno footprint, which is pretty large at the end of the day. So the new design replaces all of these components with a Johansson integrated passive device. So this is one chip, one very small chip, rather than the 10 individual components here. And at the same time, the entire design was squeezed into a very small footprint. So if you look at what the result of this was, is we have this new, again, it's the same end form factor around the outside of it. It's a Arduino Uno footprint, so you can plug it into all the same things you used to plug it into for evaluation. But the key is that the entire design is fit onto a very small form factor right in the center of this carrier board here. So this is just about 13 millimeters by 13 millimeters. And that's size optimized, it's cost optimized, and most importantly, it's RF optimized. And also for heat dissipation, everything was designed with in partnership with the Semtech guys, so that it works exactly like their old design, but it's optimized, right? So then you can take that design, everything about that, and take it exactly down onto the end customer's application, and you know it's going to work. Obviously, there will be other things around it. The customer will have other pieces to their application, the microcontroller, peripherals, and anything that you need to set up will be around that design. But as long as you keep that RF design unchanged, then we know that it's going to perform as it's supposed to perform. Again, it's got 3 variants on this reference design, the ones I talked about before. There's one for the 61, the 62, and the 68. All 3 of those are footprint compatible, as we talked about before. So essentially they're variants on the same board, with just the chip replaced between those. We have software support for this. Traditionally, the legacy Semtech reference design was really targeted for STM, for the ST Micro family of devices. This will work for those as well still, but we've added support as well for Nordic and Silicon Labs system on chips as the microcontrollers, which is really important because those are used for a ton of Bluetooth devices, especially, which what we're seeing more and more of is that people are doing multi-radio devices. Bluetooth is almost a given on a lot of IoT devices these days. That it's very useful for a lot of things, including provisioning. So having that there is useful. Having the support for more microcontrollers was also an added benefit of going with this reference design. The bottom bullet here is huge. That all those radio design files, everything about it for this little tiny board here is open source from our side. So we're providing all of it for end customers' use, including the Gerbers, including the layout, including the schematics. All of it can be used and should be used by end customers, which really jumpstarts the design and prevents it bypasses a huge part of the design for customers that takes a long time and is something, frankly, that gets messed up a lot. So if you put it in and you don't do the design exactly right, you don't do the RF exactly right, you're not going to have the results that you want at the end of the day. So where do you go to get all this stuff? So it's all hosted on our side on Connected Development. So our website is here, connecteddev.com. So if you go to our website and you go to projects, there's a CD reference designs that you can get to here. You click on that, and then you can either follow the Nordic integration or the Silicon Labs integration path. There will be some choices underneath that to go whichever direction you want to go. And then there's resources for each one of those MCU integrations at the end of the day. So I'm going to focus a little to start off with here on the Nordic side of things a little bit. So going into what the page looks like and what the resources look like here, you can see that there's a reference design data sheet. That's each one of these are labeled. So that's what it looks like and what it sounds like. It's just a data sheet related to the actual radio board and everything around it. The second thing is precompiled demonstration code. I'll get into what those demonstrations are in a few slides. But basically, I'm going to give instructions and show how to compile code, how to get it all done. I guess I hesitate to say if you're lazy, but if you maybe don't have the time to go through that and set up all the resources and install tools and things like that, maybe you just want to get up and going quickly with the demonstration. This precompiled demonstration code lets you go and grab the actual hex file, binary files, and program them directly onto the the host MCU, and you can get up and going within 5 minutes. So it's kind of a bypass to having to go through and compile things on your own if you don't want to go that path. Then the two examples that we provide from a software perspective are there's a LoRaWAN example, and I'll go into the details of what this is in a couple of slides. And there's also a ping pong demo, which is more point to point. Again, I'll cover that in another slide. And then this link right here is the link to all those open source hardware design files that I talked about. So that's where you go to get those Gerbers. You go to get those schematics. Everything is available right there. So I'm not going to go through each one of these necessarily in detail, talk about just a high level prerequisites to run the demos for the Nordic side of things. And I'll get into Silicon Labs near to the end of the presentation. But what you would need in the ping pong example, you need the MCU, the microcontroller that drives the radio. You need some of those. So you would need, for the ping pong, since it's two devices talking between each other, you need two of each. So you would need development kits. In our case, our examples are built on the Nordic NRF 52840. So you need a couple of those dev kits. And then, of course, two of the transceiver boards that I just talked about. And in the LoRaWAN case, you would only need one development kit, and then you're talking to a gateway. So then, of course, you would need a gateway that you're talking to. There are multiple gateways out there that do LoRaWAN that you can buy. I gave an example here in the presentation of one that's very cost effective and also comes with a limited amount of data, so that you can visualize your whatever you're sending up to the cloud. So that's referencing a things indoor gateway. Again, the link is right here. So you could use other gateways. There's nothing magical about the things indoor gateway. Again, it's just a kind of a lower cost option that's useful for demonstration purposes. But there's other gateways like from Multitech, for example, that are perfectly good and higher end gateways, really, that you could use for your application. You can also, for this example, hook up to public LoRa networks. So, for example, Senate, so there's some other public LoRa networks out in the US that you can attach to for demonstration purposes. Software, there's Nordic tools. Again, the instructions will go through this a little bit more, but this is built around Nordic tools for this demo right here. And then some references. I would definitely highly recommend that anybody going through this looks through this Nordic online course. Very good, very well set up, and it gets you the idea of what the tools are and how you use them. So that's highly recommended if you're doing any kind of compiling of these demonstration examples. And then again, down at the bottom, if you're using that things gateway, this is a good resource right here on how to set up that gateway and how to visualize any kind of data that you're uploading from your devices. So the ping pong. Oh, and by the way, one thing I didn't mention on the previous slide is one of the other things on the slide or on this web page, I should say. If you want to buy the dev kit, obviously there's a couple links that you can go to, either Mauser or Symmetry, and purchase the actual references site. So the ping pong demo is set up exactly like it sounds like. So it's two devices that you program separately, and then one sends a LoRa ping out and one responds with a pong. So very, very useful for range testing, especially as, if you've got a customer who's interested in seeing how far LoRa, the actual modulation scheme can get them. This is a great way to go about it, right? You set up these two devices, and they blink on and off when they receive data from the other guy. You can just start walking away and see how long they go. And they're also set up to show the data, signal strength received, and basically quality of service on a terminal line. So you can see actually that if you connect it up with a terminal emulator program, you can go and see that. So if you go to the how-to guide for the LoRa ping pong demo, and you go and you click on that, you'll get something that looks like this. So basically, very detailed line-by-line instructions about how to go and set up this demonstration. And I'll go through this real quickly just to at least point out the sections here and what's involved. I'm not going to go through it line by line necessarily, but I want to show the general idea. So obviously we've got our dev kit down here. You plug in the transceiver reference design into that. This is that Arduino footprint is built already onto the Nordic dev kit, so you just plug it in, right? That's all you really need to do from a hardware perspective to get the demonstration up and running. Again, some references. I mentioned the online course that's highly useful, and SDK how-tos, things like that. So you need to go ahead and install the Nordic tools. Nordic, their IDE is based on Visual Studio Code. So basically you need to get that installed and set up. So these instructions get you through all that. You obviously need to have Git to go out and fetch the repositories and the code from Nordic, and actually our code as well. So all the instructions are set up there, but you need a Git account to do that. That's easy to do. That's something you could just look up online if you've never done it, but that's everybody uses it these days, so no issues there. Getting the application code from Git, and then you'll update the workspace in Visual Studio Code, and basically grab all those pieces together and compile them. So you have lots of instructions in here on how exactly to do that. I'm not going to go through that step by step, but you can just follow this with the documentation that we have on our website. So once you do that and you've built your configuration and you hit the compile, then you can download that hex file, the binary, down to the microcontroller unit, which is controlling the radio board at the end of the day. And you'll see once you flash that the device will start sending out information over the terminal program down here. So you can see that the pings are going out. You can see that the pongs are going on. Of course, this is assuming that you've programmed both the ping unit and the pong unit. They're both operational at the same time. You can see that the signal strength and the signal to noise ratio are showed over here. As I was saying before, now that you have all of that, you can start actually walking away while monitoring all this, and you can get a really good sense of how far your LoRa application is going to be working, which is hugely important for understanding range. Every customer, when they're using LoRa, are going to be asking that. That's almost the very first thing that they're going to be looking into. And really, that's it. There's a couple of appendixes down here, which I won't be going into, but some more details about things that are more advanced user top operations if you need to get into that. So I'll close that out. Okay, so the LoRaWAN example is very similar to the ping pong example, but it's a device connecting up to a cloud application through a gateway. So it's not a point-to-point, it's going up through LoRaWAN, more of a networking application. This is probably the more typical example you're going to see out in the real world, that people are going to be using LoRaWAN for their IoT devices. So very, very similar in how all this is set up and works. Just like the ping pong demo, there's a link that you can follow. I'm going to go ahead and click on that one as well. And you can see that the instructions look a lot similar. Obviously, if you've already set up, installed all the tools from the ping pong demo, you don't need to do it again for this. Also, obviously, there's some differences in the code and things like that, that you're going to be fetching different applications and things of that nature. So these instructions are specific to the LoRaWAN, very, very similar to the ping pong. One thing to note as you're going down through this one is that to join any LoRaWAN network, you're going to have to configure the join credentials. This is going to have to match up between your device and also the network. So this gives instructions on how to actually set up those keys in the EUI and things like that. So again, that's got to be programmed on your devices and also match up with whatever you have programmed in your gateway. And obviously, this is for authentication and security reasons, that you don't want just anybody to be able to join a gateway. It needs to be somebody who's trusted and that you know. So again, similar download to the target. And once all that's done, you can see, and again, in the terminal, once you get it up and running, the debug messages will be put out there and you'll see it joining up to the network and what it's actually doing. Okay, so completely shifting gears here a little bit. Amazon Sidewalk is super interesting technology that's gaining a lot of traction now. So for those of you who don't know, Amazon for a couple of years now at least has been kind of stealthily building out a call it an IoT network. And basically what the idea is that individual users, also and consumers, are sharing their Wi-Fi network, their home network connectivity with IoT users that are in their neighborhood, so within range of their home. And the way that they've been doing this, being Amazon, is that devices, consumer devices like the Echo Dot, like Ring doorbells, things like that, have had this connectivity built in them for a long time now. They've just, over the last, I think it's about 6 months, have started turning that on so that people can actually use it. But basically what it does is that a user opts in and says, I will allow other devices in my neighborhood that I can see to use my bandwidth, my home bandwidth, which typically isn't much because, again, these are low bandwidth type applications. That you can carve off a little bit and people can use that as a tunnel through your home up to the cloud. So really interesting if you think about it, right? That enables a lot of applications that previously would be very expensive. Let's think, like my favorite example, of course, is pet trackers, right? Putting a cellular device on a pet tracker gets you to find your pet anywhere that they might be, but it tends to be expensive and battery expensive as well, right? So maybe a better option for a pet tracker would be, what if I could track my pet in my neighborhood and my surrounding neighborhoods? That's probably going to solve 99% of the cases where your pet gets out your front door and goes someplace, right? So sprinklers, lighting systems, anything that might be a little bit beyond the range of your home Wi-Fi to connect up to, even child tracker, right? Something that you can see where your kid is around the neighborhood. All this would be ideally suited for this. So the way Sidewalk works, and the reason I'm bringing it into this presentation, is it has basically 3 forms of communication. You've got Bluetooth for which is obviously the short range type thing. A little bit longer range you can go through with FSK. Don't really need to understand that necessarily, but it's just a different modulation scheme. And then long range, well, it uses LoRa. So the same Semtech chips that I just talked about before can be used and are used for Sidewalk type applications where they're enabling LoRa for those applications, right? So down here is kind of a picture of this. Might be a little bit hard to see, but basically you can see that there's a center home and some homes around you. You can see those Amazon devices are scattered throughout this network, and then different things that you can do with that: solar power monitoring, air quality monitoring, noise emissions, whatever it is, right? So that it's your typical IoT applications. So how does everything I just talked about work with Amazon and Sidewalk? So we've got a Sidewalk demonstration that's working, and I'm going to shift gears over here to Silicon Labs. So Silicon Labs has got some fabulous demonstrations and a lot of resources. Nordic has kind of the same thing, but for right now, I'll target Silicon Labs in terms of this discussion, that they've got Sidewalk demonstrations. So hardware-wise, you can use that exact same transceiver development board that I've been talking about before, and connect that. You would need, obviously, some kind of Sidewalk-capable device gateway to talk to. So there's various devices that are out there that are already capable. This is a link right here to Amazon site where they show exactly which devices have the Sidewalk technology built into them. And then Silicon Labs has got a really cool Pro Kit for Sidewalk, which has got everything you need in it to enable this, right? So it's got the MCU development kit, just like on the Nordic side, it was the 52840 in this instance. It's the equivalent on the Silicon Labs side of things. So you get the dev kit, and then you get all the connectivity that you need to attach the LoRa transceiver board, which I'll go into in a second. For Silicon Labs, their IDE is Simplicity Studio. Great. Whoops. Oh, I just clicked on there. It's got a great IDE environment that has all the examples built in, very easy to use. So that needs to be installed. And then the bottom reference there is getting started resource from Silicon Labs on how to do this entire demonstration. Okay, so if you follow those links and you follow the instructions, there's basically two paths you can go through on the Sidewalk demonstration. One is using a KG100S radio board. That's more of a pre-built everything in it radio board. That's not what I'm focusing on right now. There's the other path is that you can attach a LoRa shield, which is what we've been talking about and all the rest of the presentation. So any places you see the KG100S versus using the LoRa shield, go down the LoRa shield side of things in that example. And our reference design, so that's referring to what I was talking about before at the beginning of the presentation. That's the legacy Semtech shield for the 12.6.1 and 12.6.2. Our reference design is a 100% pin and functional compatible with that exact same shield, and has all the advantages that we talked about at the beginning of the presentation, that you can take that design and put it down onto an end application, be RF friendly, and you know it's going to work from a certification perspective. So, but all the instructions work exactly the same way. There's an adapter board that's provided with a Pro Kit from Silicon Labs that you plug into the site. This is the dev kit from Silicon Labs here. You plug in the adapter board. This is the radio, the MCU in the case is a daughter card that plugs into that dev kit. And then the actual radio board plugs into that adapter board. Again, it's got that Arduino footprint right there. Just plug it in, off you go. You've got everything you need from a hardware perspective. And then if you go into the software instructions on that and how all that works, you can follow the instructions exactly as they're laid out on the Silicon Labs instruction tutorial, and just put our shield instead of the legacy Semtech shield. Everything works exactly the same way. So nice, easy way very cool way to get up and going with Sidewalk. And again, for anybody who's hasn't looked at it, I would definitely encourage you to take a look at Sidewalk in general. I think it's going to be something that's going to be taking off over the next coming months. It's already gaining a lot of traction, and I think it's going to continue to be a lot more once people know that it's out there, and that starts building up a portfolio and library of devices to work on Sidewalk. So nearing the end here of the presentation, as a conclusion, the things I would like you guys to think about as you're looking at this is that this transceiver reference design that we're providing really gives you everything from a hardware and software perspective to jumpstart things. It's really unique that we're providing this open source that anybody can take that, and that it's been RF tested, FCC pre-tested, everything else. So you can just take that and put it down onto your end devices, and off you go, right? It's really a lot of peace of mind, gets people up and going, gets your customers to market a lot quicker at the end of the day, which is, of course, for everybody key. Right. Software examples also are out there. They exist. There's lots of really good examples for the LoRa point-to-point stuff. There's lots of great examples for LoRaWAN network stuff. There's lots of great examples, as I just went through, for the Amazon Sidewalk side of things. So my word of wisdom here is do not start from scratch. Start with something that's already out there. Start with something that exists. And use those existing building blocks to go from. There's no reason to begin a design from scratch at the end of the day. As I mentioned at the beginning, connected development, this is what we do. We're a wireless design company with our partnerships and our sister companies with distributors. We handle things, including all the design services, including all the RF, including all the certification, including build type stuff. We also have, with the distribution side, the ability to source components, which, with all the supply chain issues that have been going on over the past couple of years, that's huge too. It's a one-stop shop. You can come to us. We can help you guys out with whatever you might need. I'll take a look at the chat here in a second on any questions that came up during the presentations. If anybody has questions that you didn't think of here, or you think about 2 minutes after we hang up the call here, feel free to reach out to me anytime. My email address is there, dave.hoover@connecteddev.com. I'm happy to talk about IoT any day of the week, so reach out to me anytime. So with that, I'll kind of wrap things up. Lauren, you still there?
I'm here.
Okay, so I see a can't hear you comment. Hopefully that wasn't anything else. Any other questions that are coming up through? Hopefully cost got handled, got his connectivity going.
Yeah, so we have a few more minutes. If anybody wants to leave anything in the chat, that would be great. We'll hang on for just a minute, Dave, and see.
One thing I will mention while people are thinking about their questions, or if they have any, this will be posted on YouTube, so you can go back and look at this anytime. Oh, Greg, your answer. Yeah, that timely question there, Greg. Thanks. Yeah, this will be on YouTube. I think, Lauren, you can either provide a link, or it's available on the Riot Education website as well, that you can just go there and look at any past Riot Lunch and Learn type recordings, and they're all up on YouTube.
Yep, that's correct. They'll be on YouTube, and then I'll also post it into the meetup page where you registered today. I don't see any other questions yet. Give it just another minute. And just a reminder, we do lunch and learns every Wednesday at 1 p.m. And you can find that at riot.org on our website, or the meetup pages that you follow us on. We do have a extra lunch and learn this week, tomorrow at 1 p.m. with Blues Wireless, if you're interested.
Great. So Lauren, I think that one's for you.
Yep, I'll post the link to the YouTube in there.
Okay. One thing I've got to leave everybody with, I've been doing a lot of sideware, but if you could see me for a second, I'll hold up the reference design. This will give you an idea of how big it is. Again, this is a Arduino footprint right there. And then if you look at that side by side, this is the actual radio board that sits on the middle of that. So that's this guy right there. It gives you an idea of how small that actual reference design is. All right. So Lauren, I think that's a wrap. Thanks, Gary. Thanks, Andy, for the words there. So we good, Lauren? You're muted, Lauren. Okay, well, I think that's good then. So thank you, everybody. Hope you have a fantastic 4th of July and maybe a day before that, and enjoy the weekend.
Thanks, Dave.
All right, thank you.
All righty.